So, okay guys, we are back with another video, that is the tutorial discussion 2 of the lesson graphs, right? So in this video, we would be covering some difficult questions than the questions that we covered on the previous session. It is on graph session 1, right? So yes, let's get started with. So here it says a stone is dropped into the water from a bridge 125 meters above the water, right? Okay, above the water level, above 100, if this is the water level, above 125 meters, it's dropped. Another stone is thrown. So one stone is dropped and the other stone is thrown vertically downwards. So the stone that was thrown, it was thrown after 1 second. It was thrown after 1 second. So, and they say both strikes the water at the same time, right? Both strikes the water at the same time. We need to plot velocity versus time curve for each of the graph, taking t equals 0 as the instance of the first stone, right? So let's initially consider a small diagram, right? Let's initially consider a small diagram. Like this was the first stone. It was released. In that case, its initial velocity is going to be 0, right? Let's assume this is the water surface, right? The second object, right? Actually, the second object was thrown. It was thrown vertically down, which means it's thrown with the initial velocity. We do not know what that velocity is. So now the thing is, this was dropped downwards at t equals 0, and this was dropped at t equal 1 second. Somehow they are saying both reached at t equal t. This reached the water t equal t. Both reached the water surface at t equal t. Somehow the distance between them, so the distance that they cover would be 125 meters. For this, we need to draw a velocity time graph, right? So fine. Let's do it. Let's draw a VT graph, maybe. Right. So how it's going to be drawn? What do you think? So if this starts from 0 velocity, it falls under what? Like it freely falls, right? The first stone freely falls. What is the acceleration of the first stone? It is it's something around a equals g, right? It falls with the acceleration a equals g, right? So right, first of all, let's draw to the first stone. So somehow the velocity like it falls under a gravitational acceleration. So from velocity 0, its acceleration, like since it has an uniform acceleration from velocity 0, its velocity keeps on increasing gradually. So how do we draw a constant acceleration in a VT graph? Simply by a line, right? Simply by a line from 0, right? From 0, it's like this, something like this, right? So we can consider it started at equals 0, and when it reached the ground, right? When it reached the ground, it has covered, but upon within t equal t time, it has reached the ground. So what might be the distance, the area? From the area, what would we get? 125 meters. The area of the VT graph gives the displacement traveled by the object. So what is the displacement that traveled by the object from t equals 0 to t equal t? It has traveled 125 meters, which means the area gives it, right? Right. Okay, fine. That is all right. So fine. So what happens is, next we need to plot the graph of the second guy. So obviously here also, the second stone also falls under the gravitational acceleration. The second also falls under the gravitational acceleration, right? So, but the difference is, initially it starts at t equal 1 second. It starts at t equal 1 second, and it has an initial velocity because it's thrown, right? So it starts at t equal 1 second. We need to understand it, right? So somewhere here, maybe, right? So it starts at t equal 1 second, right? Starts at t equal 1 second with a velocity u, right? T equal 1 second. So, and then it will move with the same, since it has the same gradient as the first stone, which means the acceleration. So at t equal t time, it might also have reached the destination, right? So at equal t time, it also has covered 125 distance. So the area, so this area gives you what? 125. This area gives you what? 125. So because like both the guys should travel, it doesn't matter at what time they start and all, both these guys travel the same distance. So what can we say? Both has the same area, right? Like both these graphs, this trapezium, right, and this triangle, they both have the same area, right? So fine. If we need to find t, we can use that actually, right? We could use that theory, right? So here this thing is not known though, right? So let's assume that velocity is v. Let's assume that is v, right? Now, what we could do is I'll write an expression for the first stone. First stone means this triangle, right? First stone. So I'll write an expression for that. First stone, right? First stone. The area is what? 125. Area is what? Half into base is what? Base is t. Base is t. Half into base into. So what is this distance? So the height is, what is this height? Let's assume that is v1, right? Can't we find this height v1? For the time being, let's write it as v1, right? We can easily find this v1 though. How? By using the equation tan theta. Gradient is equal to tan theta. So here the gradient is what? Tan theta. So tan theta is what? Opposite over adjacent. So we know tan theta is opposite. Opposite is v1 over t. So tan theta is what? The gradient is g, right? v1 over t. So obviously we are going to get v1 to be as gt. So the first equation we can rewrite as 125 half t. v1 is what? gt, right? So gt squared, we can write it as 250, right? It's fine. We have written one expression for this guy. From this straight away, we could find the value, right? I guess, isn't it? Isn't it the case? We can straight away find the value. I guess it would be something around like g is 10, right? T squared 250, 10 to t. Okay, t is going to be what? 5 seconds. So t is going to be 5 seconds. We have found that. Right? We have to, okay. So what they're asking is find the time stones hit the water and the initial velocity of the stone. Okay, we have found this. This is what? This is t equals 5 now. We need to next find initial velocity of the second stone. We need to find the initial velocity of the second stone. This velocity u, right? We have to find the velocity u. So what I would do is I would once again use this area, right? I would once again use this area. But what would be the area of this trapezium? It would be 125 because it also traveled the same plane. Both was this was also thrown from the same height, right? So it should also travel 125, which means this area should also be 125. I will write an expression for the trapezium. Half into perpendicular height is t minus 1. Perpendicular height is t minus 1. And we have to add these two parallel distances, u plus v. Right. So for second stone, right, 125 is half into perpendicular distance is t minus 1 into v plus u, right? Now this is 250, t minus 1. What is t? T is 5. 5 minus 1 is 4. V plus u, right? So v plus u is equal to 250 divided by 4. 250 divided by 4. This is one equation. Also, we can write another equation. How? By getting the gradient. This is also theta, right? If this is theta, this was theta, right? This is also going to be theta, right? So tan theta is equal to what? Now tan theta is going to be opposite over adjacent. Tan theta, I will write it here itself, right? Tan theta is what? Opposite is v minus u over what is the adjacent? Adjacent is 5 minus 1. So 4. 4. T is tan data is 10, right? Because it's V. Right. So V minus U is equal to 40. So what we need to find is U. So therefore I will subject V. 40 plus U. 40 plus U. V is 40 plus U. So here I will substitute 40 plus U 250 over 4, right? So this is 2U, 250 over 4 minus 40. If you simplify this value, right, you're going to get something around 11.25 meters, right? If you simplify 11.25 meters per second, this would be the answer. It was a good question, right? So I hope you understood that question. Let's move on to another one. Right. So let us go for the next question, actually, right? The next one is somewhat easy though, right? It says a train traveling between two stations, right? This is regarding a train which is traveling between two stations. Okay, starts from rest. We need to remember that it starts from rest, moves with a uniform acceleration, right? Okay, it moves with a uniform acceleration first, and then a uniform velocity, and finally comes to rest at other station having a uniform deceleration. If the time ratio taken for these three paths is 1:8:1, and the maximum velocity is 60 kilometers per hour, find the average velocity of the train. Find the average velocity of the train. First of all, we need to plot this, right? So we will try to do this using the VT curve, right? So let us see what we could do, right? This is V equals meters per second, right? So, yeah, sorry about that. Right, let me change it. Fine. So this is T is equal to T axis. So the train is initially moving from rest, which means it starts from zero velocity. At T equals 0, it starts from zero velocity. So it initially accelerates. If it accelerates, it should have a uniform acceleration, correct? It should have a uniform acceleration. All right, fine. So it's going to have a uniform acceleration for around this much of a time, for example, right? And then they are saying initially starts from rest and moves to the uniform acceleration first, and then a uniform velocity, and then a uniform velocity for a certain time. So it moves with a uniform velocity for a certain time. Let's assume this amount of time. Uniform velocity means the same velocity, right? Right. And then comes to rest. Finally comes to rest means reaches zero velocity. Reaches zero velocity. Comes to rest with a uniform deceleration. How do you denote decelerations? How will we denote decelerations? Obviously, so it's a uniform process once again, right? This, right. So one thing that we need to notice is, so actually there are three portions here, right? We have three portions here. Is let's assume, okay, the time taken, like they are also they have given a comment on the time taken. If the time ratio between the time taken for these three motions is 1:8:1, which means what do they say is if the time taken for the uniform acceleration is t, and then the time taken for the if the time taken for the uniform acceleration is t, then the time taken for the uniform velocity is 8t. Time taken for deceleration is t, right? So that is what they are trying to argue, right? So this is, we have to consider this as t, right? So, and then we have to consider this as once again t, right? 80, this is going to be 80, and then this will be once again t, right? And then also they have commented on the maximum velocity the train reaches. It's when time increases, its velocity also keeps on increasing, but the maximum velocity that it reaches is what? It is 60. They have given it's 60 kilometers per hour. If it, like, how can we convert 60 into 60 kilometers to meters per second? 5/80, right? 5/80. So if we simplify this, we would be getting something around like, let me check, right? 60 into 5/80. It's going to be 50/3, right? 50/3 meters per second. So I will mention it here as straight away 50 over 3 meters per second. Or else we could go with, like, rather than finding these things, we could go with, if we consider the time axis in kilometers per, if we consider this in kilometers per hour and the time axis in hour, also we can deal with, right? So this is 60 in that case. We would get the final answer also in kilometers per hour. That's fine. The answer given is, the answer expected is also in kilometers per hour. Right? So how would we find, what do they ask now? Find the average velocity of the train. This is the motion of the train. We need to find the average velocity. How would we find the average velocity? Average velocity is the total. What is average velocity? Average velocity, average velocity of a motion can be found exactly how? Total distance traveled divided by what? Total time taken. What is the total distance traveled? What is the total distance traveled? How can you find the total distance? By getting the complete area of this curve, right? The total area of this curve is going to give the what? Total distance covered. So we can simply find that this is a trapezium. Half into perpendicular height is 60. The height of the parallel sides, the length of the parallel sides are 80 and 10t, right? So average velocity, total distance is half into perpendicular distance is 60, and addition of the two parallel sides are 80 plus 10t, divided by the total time taken is what? Total time taken is t. 80 plus t is what? 10t, right? 10t. If you simplify this, you are going to get 54 kilometers per hour, right? So you are going to get this answer. So this is not a very difficult task, as I mentioned, right? So yes. All right. So we have to discuss the next problem. That is, we'll see this. So here it says a car starts from rest, right? So this car starts from rest, moves in a straight road, gains a velocity 54 kilometers in 10 seconds, which means it moves with a what? It moves with a uniform velocity, right? It moves with a uniform velocity, gains a velocity. It starts from 0 and it attains this speed, means in 10 seconds it gains a velocity. Let's draw it then and there, right? It'll be easy. From 0, right? Okay, sorry. Right? So from 0 velocity, right? Can you say? All right. So yeah, I'll use. Let's draw it then and there itself. It'll be easy, right? Right. Within 50, they attain 54 kilometers per hour in 10 seconds, right? So this is within 10 seconds. Right. So this is within 10 seconds. This is the time axis actually, right? The velocity axis, meter per second. So we need to also see 54 kilometers means kilometers per hour means in velocity, in meters per second, it is what? It's going to be 15 meters per second. Do the calculation properly, right? So it's going to be 15 meters per second, right? So we will consider this to be as 15. All right. Now they're saying, having moved with the same velocity through 0.5 kilometers, the same velocity, they are moving same velocity for 0.5 kilometers, which means they are moving with the same velocity for further what? For further around 450 meters, right? They're moving the same velocity for 450 meters, right? So, right, let us do that. So yeah, sorry about that. Same velocity for 450 meters, right? So what is the time taken? The time taken is, it's actually not known. The time taken is not known, right? This is what we know is, this is 450 meters. Only this is known, right? Fine. And then this car accelerates to reach the velocity of 72 kilometers per hour in 10 seconds. So 72 kilometers per hour means what? 72 kilometers per hour means it is 20 meters per second, right? So within 10 more seconds, they are accelerating, right? For how long? For 10 more seconds, right? They're accelerating for 10 more seconds, right? Right, accelerating for 10 more seconds. So this is 10 more seconds, right? This is 10 seconds, right? So finally they are reaching what velocity? They're going to reach a velocity of 20 meters per second. And then what happens? Right, then it moves another 1 minute with this velocity. Another 1 minute is going to be moved with this velocity. Which means it's a uniform velocity. 1 more minute is going to be moved with that velocity, right? 1 more minute, which means the in seconds, if you consider, it is 60 seconds. For 60 seconds, they are going to move with the same velocity, right? Right. Okay. So find that, and then they're saying finally stops with constant deceleration 2 meters per square second. Finally, they stop by moving with a constant deceleration of 2 meters per second, right? So what we could do is, like, they are stopping, right? They are gonna stop. They are gonna come to rest, right? So the time taken is not known here, right? The time taken is not known here. What is known is this constant deceleration is 2 meters per square second, right? This is, let's assume, T2, and this time was not known, right? This was T1. Now, what do they ask? Find the average speed. Once again, we know what average speed means. What average speed is total displacement, or sorry, total distance. You can say total distance over time taken, total time taken. Do we know all the data in here? No, we do not know T1, we do not know T2. Can't we find T1 and T2? We can easily find T1 and T2. How? So they have given a data here. That is this area, the area covered, like this area is what? This area is 450 meters, it seems, which means this is 50, this is T1. So T1 into 15 is, T1 into 15 is 450, which means T1 is going to be what? T1 is going to be 450 divided by 15 is, it's going to be 30, right? T1 is 30 seconds, right? So now we do know that 30 seconds, right? We need to find this T2. Can we find T2? Obviously we can find. If we take this as theta, right? The gradient opposite over adjacent, tan theta is opposite over adjacent, right? Tan theta, right? Tan theta is, right? Opposite is what? Opposite is 20 minus 0. Opposite is 20 minus 0. Adjacent is what? Adjacent is, what is this? Adjacent is T2. It's not positive T2, it's negative T2. Adjacent is negative T2, right? Negative T2. The tan theta means acceleration, but it is a deceleration. Minus 2, 20 over negative T2. Negative cancels out. So T2 is going to be what? 10 seconds, right? T2 is going to be 10 seconds. So fine. Now we know all the this thing, the times. Can't we find the total time taken? We can. Can't we find the total distance traveled? We can, because like this area would give the total time taken traveled in acceleration, and then like we have to find the total area, right? Separately we'll have to find it, I guess, right? We have to separately find it. This, right? This area, let's consider it as 1. Area 2 is to be as 3, 4, 5, right? So the total area, the average speed is, right? The average speed is going to be 1 plus 2 plus 3 plus 4 1, 2, 3, 4, and 5. There are 5 areas that we have to deal with, and the total time taken. Total time taken is 10, 30, 40, 50. 50 plus 1, 10 is 60. 60 plus 60 is 120. Right? It is simply 120. The area of the first, you like finding the areas is not going to be difficult, right? So like half into base into perpendicular height. This of course is given area. So then this is the trapezium, half into perpendicular height into this height is 50. This is 20, right? And then this is a rectangle. Finding this area is not going to be an issue. This is a triangle. Every data is given. So you can easily find the average speed, right? I'm not going to do the simplification. So it's going to give you something around average speed is going to be like average like total distance. You will get something around 1,300 meters, right? So divide by yeah, total distance traveled is going to be something around not 1,300. It's going to be something around 2,000. 2,000. This is 120, right? So you're getting 16.67 meters per second. This would be the answer, right? Okay. So yeah.